divisors 1, 2. So you can't take 3. So then we'll get 4, then 5, then 10, then 20. See, these are the divisors of 20. Now, see, by looking at this, we can easily understand. Here we have to find out number of positive divisors which divides 30 but not 20. See, for example, let us take 1. 1 divides 30 and 1 divides 20 also. And take number 2. 2 divides 30 and 2 divides 20 also. See, now 3 divides 30, but 3 does not divide 20. Now look at here. 5 divides 30 and 5 divides 20 also. Now 10 divides 30 and 10 divides 20. Now look at here, what are the numbers which does not divide? We can clearly see here 3, 6, 15 and 30. So here, so these divides will divides 30 but does not divide 20. So what do we understand by this? See, number of positive divisors which divides 30, which does not divide 20 means, see what you should do. So number of divisors. So the logic here is, you can clearly observe here. What are these 1, 2, 5, 10? See, have you observed what are these 1, 2, 5, 10? Are they divisors of 10 or not? So these are divisors of 10. So these are divisors of 10. So how can we say now divisors of 10? 1, 2, 5 and 10. Divisors of 10. So divisors of 10 are common in both divisors of 30 and divisors of 20 also. Right? Now, see, now we have to eliminate these divisors. See, we have to exclude this 1, 2, 5, 10. So 1, 2, 5, 10. So how can we exclude those? So we have to find out number of divisors. We have to find out number of divisors of 30 minus number of divisors of 10. So how do we get to 10? Is 10 is the HCF of 20 and 30 or not? We can clearly observe 10 is a HCF of 20 and 30. So number of divisors of HCF of 20 and 30 we should subtract. So I hope this logic is clear for you. So number of divisors of 30 minus number of divisors of HCF of 20 and 30. So these divisors if you subtract, then we will get answer. This is the logic we have to follow. See now, so we have one question, previous RMO question. See now, this is previous RMO question. Number of divisors of, see now this is the question asked in previous RMO exam. See, number of positive divisors of 10 power 99 but not 10 power 990. See, just now we have seen the logic. So how to find out here? So the answer is number of divisors. Number of divisors of what you will get? 10 power 999 minus number of divisors of HCF of 10 power 998 and 10 power 990. This is the logic we need to follow. See now clearly we can say that what is the prime factorization of 10 power 999? Is it 2 power 999 into 5 power 999 minus what is the HCF of 10 power 998 and 10 power 99? It is clearly 10 power 998. What is the prime factorization of this? So divisors of this number minus divisors of 10 power 998 can be written as 2 power 998 into 5 power 998. So now we can clearly see what are the divisors of this. You can write, we know that 999 plus 1 into 991 plus 1 minus this will be what? 998 plus 1 into 998 plus 1. So when you multiply this, this is 1000 square minus this is 999 square. Is it in the form of a square minus b square? So which can be written as 1000 minus 999 times 1000 plus 999. See, look at here, this is 1, 1 times 900 and 1 times 1919. So 1919. So which can be written as 1919. So these many positive integers which divides 10 power 99 but not 10 power 990. See, like this we can easily find out. So hope it is clear. See, let us look at the next question. See, now this is the question asked in previous Ioqm 2021. So this is the question asked in Ioqm 2021 KV and JNV question. See, now here they asked, what is asked? Find the number of positive integers. Find the number of positive integers n such that highest power of n, highest power of 7 dividing n factorial is 8. See, we have already learned right yesterday, exponent of prime in n factorial we have learned. What is that? So this is integral part of n over 7 plus integral part of n over 7 square plus and so on. Look at here the power is what? 8. So now we can write here. So exponent of 7. So exponent of 7 is what? 8. So 8 is equal to what? You should get n by 7 plus n by 7 square, like this it should be. See, what is the n value we can take? So n, see, this value should be greater than 7. So generally n by 7 is minimally greater than or equal to 7. See, this value, minimum value 7 should come. So what is the least possible value of n here? N must be 49. Because n is equal to 49, then only you will get here exponent 8. See, let us check here. So 49 over 7 greatest integer function plus 49 over 7 square plus 49 over 7 power 3. See, what is this value? This is 7 plus what about this value? 1, 8. So now we can clearly say that in 49 factorial, we can clearly say that 49 factorial exponent of 7 is 8. So 7 power 8 will be there into some constant will come. 7 power 8 exponent will get. So this is one factorial, 49 factorial. See, next 50 factorial also will get exponent 8 only. See, you can take 50 here, 50 by 7 plus 50 by 7 square. So plus 50 by 7 power 3. See, we can clearly see that here 50 by 7, what is the integral part? So integral part is 7 point something, right? 7 only. 50 by 49, 1 point something, integral part 1 only, plus 0. So this is 8. See, here n can vary from values n 49, 50, 51 until we get next multiple of 7. Until we get next multiple of 7, we will get exponent is 8 only. So until 55 we will get. So you check for 56. See, let us check for 56. So 56, what will happen? 56 by 7 plus 56 by 7 square. See, here we are getting 8 here. 8 plus here we are getting 1. So 9 you will get. So until 55, we can check for 55. 55 by 7 plus 55 by 7 square. So what do you get here? So this is 7 point something. 7 plus 1, 8 will get. So in the question they are asking number of values. So how many values will get here? 49 to 55. We can clearly see here what are the values which satisfies this question. N is equal to 49, 50, 51, 52, 53, 54 and 55 until we get next multiple of 7. So total 7 values. So they are asking number of positive integers. So answer is 7. So 7 values it will satisfy this equation. Okay, is it clear? See, another question which is asked in Ioqm, KV and JNV. So this is also a simple question. See, look at here. Find the largest positive integer n such that number of integers in the set 1 to 1 to 3 and so on up to n which are divisible by 3 equal number of integer which are divisible by 5 or 7 or both. Okay. So now here we can clearly check here. So what is here? N, right? N which are divisible by 3. So we know that the positive integers we know 1, 2, 3, 4, 5, 6. So 7, 8, 9 and so on. Yesterday we have learned, right? For every 3 consecutive natural numbers, one number divides by 3. 1, 2, 3 you check. So 3 will divide 3. Now you can check next 3 numbers, let us check 4, 5, 6. So 6 will divide. So 3 divides 6. Next 3 numbers you check 7, 8 and 9. So now this is 9. So 3 divides 9. For every 3 consecutive natural numbers, one number divided by 3. So that is multiples of 3. Now similarly, now here they are asking a divisible which are divisible by 5 or 7. So you take the numbers 1, 2, 3, 4 like this. So multiples of 5 you take. So 5 you take. What are the multiples you can take? 5, 10, so 15 and so on. In this one you will get 35 like this will be. Multiples of 7 you take. So 7, 14, 21, 28, 35 will be. Look at here numbers which are divisible by 5 or 7 are both. So 5 or 7 means look at here 35 is repeating in both the values. So here in the question clearly mentioned that find the largest positive integer n such that number of integers in the set. So what are the values you should take? 1, 2, 3 and so on up to n which are divisible by 3. First let us calculate how many numbers are divisible by 3. We know that for every 3 consecutive natural numbers, one number is divided by 3. So I can write integral part of n divides 3. N by 3 integral part value is number of numbers which are divisible by 3. So which is equal to divisible by 7 or 5 or both. How many numbers are divisible by 5? So integral part of n by 5. Because for every 5 consecutive natural numbers, one number divides by 5. Plus, now similarly for 7, how many numbers are divisible by 7? So for every 7 consecutive natural numbers, it divides by 7. So n by 5 plus n by 7. But here the problem here is, see a few numbers which are divisible by 5 and 7 also. What are those numbers? We can clearly see here 35. Okay, then we can get 70 next number. So 35 multiple. So we should also subtract that. So minus n by 35. This is the number. Now we can clearly see here n by 35 plus n over 35 is equal to n over 5 plus n over 7. See, they are asking largest integer. They are asking largest positive integer. See, we can take here instead of n, you can take 1, 2, 3. See, minimum values will possible. What is the maximum value possible? See, the maximum value is up to 35 you can take, not more than that. So you can easily clearly say that n should be 35. See, you can verify for 35. See, 35 by 3. 35 by 3 plus this is 35 by 5 is equal to 35 over 5 plus this is 35 over 7. So what is your integral part? Is it 11 plus? So this is 35, this is 1 is equal to here 7 plus this is 5. So this is the maximum number which will satisfy. If the n value exceeds 35, then it won't satisfy. So you can take, for example, if you take 36 by 3, this value will be, so and 36 by 5, this integral part is 1 only, 12 plus 1. But whereas here right hand side, it won't increase. So n over 5 plus n over 7. So now left hand side part is greater than right hand side part. So 36 by 5, how much? So if you take here and 36, so it will be 7 plus 5. So it cannot be equal. So the largest value is 35. So largest integer which satisfy this one is 35. So this is the previous year Ioqm question, Ioqm, KV and JMB. So hope it is clear. Okay, see, now we are going to learn about LCM and GCD. So everybody knows about basic GCD. So I'll go to GCD. Everyone knows. So this is greatest divisor, greatest common divisor. See, let us consider two numbers. So let us consider two numbers. So GCD we already know. So I'm going to teach the properties here. See, when you consider two numbers, let us say 3 and 4. Let us take for example. Now 3 and 4, what is the HCF or GCD? 3 and 4 GCD is 1. See, when you add this, so 3 plus 4 you add. 3 plus 4 is what? 7. Now here 3 plus 4, 7, 7 and 3 you take. What is the GCD here? So this GCD is 1. You take 7 and 4. What is the GCD here? Also is 1. Take multiple also. For example, 3 plus 3 into 4. 3 plus 4 is what? 7 and 12. What is the GCD of this? This is also GCD 1. So now we need to understand when two numbers GCD is 1, we can say they are co-primes. So let us take example. If A and B are co-primes, means what is the meaning of that? GCD of A comma B is equal to 1. If they are co-primes, the GCD is 1. Now GCD of A plus B comma A is also 1. Okay. Now GCD of A plus B comma B is also 1. Okay. These are the properties you should know. And you can also say GCD of A plus B comma AB is also 1. So we can keep on adding or subtracting. So we can also subtract also. See, let us take example 3 comma 4. See, the GCD of 3 comma 4 is 1. Okay, and you can subtract 4 minus 3, 1, right? So 1 comma 3 HCF is also 1. So we can clearly write here GCD of A minus B comma A is also 1. So where A greater than B, that should be a positive value. So like this multiples we can write GCD of A plus BK. So A plus BK comma A. So this HCF will be 1. So like this we can write. See, now based on this, and another important point, every two consecutive numbers GCD is 1. GCD is 1. So you take 1, 2, 3, 4, 5, 6, 7 and so on you take. Every two consecutive numbers. So 1, 2 HCF is 1, 2 and 3 HCF is 1, 3 and 4 HCF is 1, 4 and 5 HCF is 1. So we can clearly write GCD of n comma n plus 1 is always 1. So every two consecutive natural numbers, so GCD is 1. So now from this we'll take one example. See, now look at this. Find GCD of the numbers 2n plus 13 comma n plus 7. 2n plus 13 comma n plus 7. See, we have already learned GCD of 2n plus 13 comma n plus 7. So we have already learned what is that GCD of A comma B. So this is nothing but GCD of A minus B comma B. We can write like this. So where A greater than B. So now what you can write here, this is nothing but GCD of 2n plus 13 minus of n plus 7 comma n plus 7. You can write like this. Now what is this value? GCD of, so what is this value now? GCD n plus 6 and n plus 7. So what is the GCD of this? So this is 1 because n plus 6 and n plus 7 are two consecutive natural numbers. Okay. So from this we can easily say that GCD is 1. Okay, and let us take another example. See, look at here, find GCD of 2 power 6 minus 1 and 2 power 9 minus 1. See, let us write GCD of 2 power 9 minus 1 and 2 power 6 minus 1, right? So here A comma B, this is nothing but what? GCD of A comma B is equal to, we can write GCD of A minus B comma B, we can write. So how to write now here? You can clearly write here, this is 2 power 9 minus 1 minus of 2 power 6 minus 1 comma 2 power 6 minus 1. So what is this value? Will get 2 power minus 1 minus 2 power 6 plus 1. So here you are going to get 2 power 6 minus 1. So what will happen now here? Minus 1 will get cancelled. Here we can take 2 power 6 common. This is 2 power 3 minus 1 comma 2 power 6 minus 1. Okay. Now 2 power 6 is not a common factor. 2 power 6 is not a common factor. So definitely that GCD is not possible. So now that is equal to this one only. 2 power 3 minus 1 to 2 power 6 minus. See, again this number is greater. You can subtract GCD of 2 power 3 minus 1, 2 power 6 minus 1 minus of 2 power 3 minus. So what do you get here? 2 power 3 minus 1. This is 2 power 6 minus 1 minus 2 power 3 plus 1. So plus 1 minus 1 cancelled. 2 power 3 minus 1. So take 2 power 3 common. So you will get here 2 power 3 minus 1. See now what is the GCD here? We can clearly see that 2 power 3 minus 1 is the GCD. So now GCD of this one is 2 power 3 minus 1. So the GCD of this one is 2 power 3 minus 1. So we can solve like this, 2 power 3 minus. So and here now we are going to solve Ioqm problems. So first, how to solve LCM and HCF problems, because these problems are very important in Ioqm. So in the last exam also they have asked many questions. So how to solve this problem? See, whenever we take any two numbers, let us take for example 12 and 15. 12 and 15. So what is the GCD of these numbers? Is it 3? So when you take 3, 12 can be written as 3 times 4 and 15 can be written as 3 times 5. See, what is the HCF here? HCF is 3. And we have to observe here one point, 4 and 5 are co-primes. See here, we need to understand this point. This is the most important point. 4 and 5 are co-primes. Because if 4 and 5 are not co-primes means what? HCF is other than 1. Co-primes means what? HCF is 1. If the HCF is not 1, what will happen? Then 3 cannot be the HCF, right? 3 cannot be the GCD. Definitely 4 and 5 should be co-primes. Then only we can say that 3 is a highest common factor. So this point we need to understand. So in an exam, if they give questions like this, what we do here is we should follow one method. So let us consider A and B are two numbers. Let us consider A and B are two numbers. So let us consider A and B are two numbers. So you consider A and B are two numbers. So now here we have to take HCF. So let us say A and B are two numbers. See, because let us consider now, let us consider GCD of A comma B is D. GCD of A comma B is D. Now how can we write A? A we can write it as multiples of HCF, right? So A is equal to dx, B is equal to dy. The most important point here is X and Y are co-primes. We should never forget this point. X and Y are co-primes. See, the numbers, whenever they give two numbers, A and B are two numbers. So A can be written as HCF into some constant. B can be written as HCF into some constant. A is equal to dx, B is equal to dy, we should consider. Now, if we consider like this, now what is the LCM here? LCM is nothing but what? dx comma dy, right? This one LCM you should take. So d you divide, what is this? X and y. Anyway, x and y are co-primes, so the LCM is dxy. So whenever you get LCM HCF related problems, we should always convert the given problem to like this: a is equal to dx, b is equal to d, and LCM is equal to dxy. Convert like this. Then we should solve the problem. So then it will be easy for us to solve. First two problems we'll solve, simple problems. Then we do Ioqm level problems. See, now let us take. See, look at there. Sum of two positive integers 52. So LCM is 68. Find the numbers. See, now just now we have learned consider numbers are. Consider numbers are. Numbers are what? A and B. You consider numbers are A and B. So now A is equal to what? Dx you should take. B is equal to what we should take? B is equal to dy. And LCM is equal to, we should consider dxy. And HCF is equal to, we should consider as d. Now sum of two positive integers. So how can I write? A plus B is equal to 52. A is nothing but what? Dx. B is nothing but what? Dy. Now you can write here dx plus dy is equal to what? 52. Now take d common, what you will get? X plus y. D into x plus y is equal to 52. This is one value. Now what is the LCM they have given? LCM is nothing but what we should consider? dxy we should consider. Now equate this one, dxy is equal to 168. Now we have two equations. Let us say 1 and 2 equations. Now we have already learned. See if what is the GCD of a plus b comma ab? That is the same as GCD of b comma a, right? A comma b, right? So now look at here. D is the HCF. Now this should be the common factor. So when do you get a common factor? This D is a multiple of, so 168, and here it is 52 also. So what is the GCD of 52 comma 168? So that will be the value of D. So what is this? Is it 4? So this is, divide this. So let us divide this. Now xy by x plus y. So what do you get here? 168 by 52. So this is 4. So here this is the 4. Now the highest common factor of this one, xy by x plus y. So that multiple is 4. See, because 4 only we should get here. 4 into x plus y. Look at here. 4 into x plus y means what? 4 into 30. See, x plus y and xy are co-primes. Why? Because we have already taken here a is equal to dx and b is equal to dy. X and y are co-primes means x plus y and xy are also co-primes. So now d must be 4. Here also you can take d must be 4. 4 into xy is equal to 168. So xy is equal to what? This is 42. Xy is equal to 42. So here from this what we understood here, see here very important point we need to understand here is x plus y and xy are co-primes. So then only d is equal to 4 only possible. Other values not possible, because when you take other values here x and y are, we don't get co-primes. Now we got, what are the values we got? X plus y is 13 and xy is equal to 42. X and y should be co-primes. So because what values it will satisfy? X is equal to 7, y is equal to 6. Or you can take x is equal to 6 or y is equal to 7. So now these are the values you will get. Now if x is equal to 7, y is equal to 7. Now we can write the numbers. A is equal to dx. D is 4. 4 into 7. So what is that number? 28. B is equal to, you can take dy. What is d? 4 into 6. So 24. You can check the sum. 28 and 24 is 52 and LCM will be 168. Okay. So this problem, we'll do one more problem. So then you will understand. So let us consider another sum. See, now look at here. This is HCF of two numbers is 18 and their sum is 324. How many such pairs of numbers are possible? See, we have already considered. Let us consider two numbers are A and B. A is equal to what? Dx. B is equal to what? Dy. You consider like this. Now, what is the LCM? Will consider LCM. You should consider as dxy. What you should consider GCD? GCD you should consider as D. Now, HCF of two numbers. HCF of two numbers is 18. So, what is the meaning of this? D value they have given, right? D is equal to 18. So, D is equal to 18. This value they have given already. This is 18. Now, their sum is 324. Sum is 324 means what? So dx sum nothing but what? A plus b, right? So A plus b is equal to 324. What is meant by A plus b? A is equal to dx, b is equal to dy. This is 320. D value is given, right? So you can take 18 into x plus y is equal to what? 324. So 18 times 1, 18 times 1. Now x plus y is equal to what? 18. So here the very important point will come. We have already learned that x and y are co-primes. X and y are co-primes. Now, if x plus y is equal to 18, we have to write x values and y values in such a way that they must be co-primes. Can we take 1 and 17? This is one such number. So this is one such number, 1 and 17. 2, 16 not possible, right? And 3 also not possible. 4 and 14 not possible. 5 and 13 possible. 6 and 12 not possible. And 7 and 11 possible, right? And 8 and 18 not possible. 9 and 18 not possible. 10 not possible. 11 and 7 is same as this. So how many such pairs are there? 3 pairs are there. 3 pairs are there. See, why the answer is 3 here? Because 1 and 7 are co-primes. How many such numbers you will get? So 1 and 17, xy. So all the values we can write. So what is that? If 1 and 17, if x comma y is 1 and 17, what are the numbers you will get? Dx and dy, right? 18 into 1, one number. 18 into 17, another number. Okay. So next one. You can take here another number is what? X is equal to 5 means 18 into 5 one number, 18 into 13 another set. Okay, this is one pair, this is one pair, and 18 into 7 one pair, 18 into 11 another pair. So these are the three numbers. You can see, check here, sum is 324, here also sum is 324, here also sum is 324, and you can also check the highest common factor. So 18 here, 18 here also 18. So how many such numbers are possible? 3 pairs are possible. Now here the important point is, in the question they mentioned only how many such pairs of numbers are possible. So 3 pairs only. For example, in the question if they mentioned like how many pairs of A comma B, how many pairs of A comma B are possible, then you can take here because x1 we can take, y 17. 17 comma 1 also we can take. When if the in the question is mentioned A pairs, if the variables if they mention, if they do not mention, we have to take 3 only. So 3 is the answer for this question. So hope it is clear. Any doubts are there? So we are going to solve here Ioqm question, because hope you will have get an idea by this time, because we proved 2 problems. See, now this is previous exam question. So what is this? Number of ordered pairs of A comma B such that A comma B belongs to 10 to 30. Okay, and GCD of A comma B, LCM of A comma B is A plus B. So I have told you one method how to follow. See, they have given A comma B, right? Now you consider A is equal to dx and B is equal to dy, right? And you can take here LCM. LCM is equal to what? dxy. And what about GCD? GCD you should take it as D, right? Now this is the equation they have given. What is that? GCD of A comma B plus LCM of A comma B is equal to A plus B. GCD of A comma B we have replaced by D, so D plus. What is M of A comma B? We should take dxy. Dxy is equal to what? A is nothing but dx. What is B? B is nothing but dy. Now you take d comma left hand side. This is 1 plus xy is equal to what about this? D into x plus y. Can we cancel d and d? Shift this side, get x plus y. So this shift here. So we can simplify this. 1 minus xy, 1 minus x minus y, 1 minus x minus y plus xy is equal to 0. We can take like this. See, now we can take common factors here. Okay. Now what is this here? 1 minus x. Here minus 1 you take common, minus y you take common. So what do so this is y into 1 minus x is equal to 0. So this is nothing but what? 1 minus x into 1 minus y is equal to 0. 1 minus y is equal to 0. Now multiply with minus. Let us write. So what you will get? X minus 1 into y minus 1 is equal to 0. We can write like this. Now here we need to solve this equation. So when do we get this one is 0? See, product of two numbers. This is like x minus 1 is one number, one expression. Y minus 1 is one expression. When the product is 0, if x minus 1 is equal to 0, it is 0. If y minus 1 is equal to 0, then it is 0. If both are 0, then also it is 0. So three cases will come. So first is considered case 1. So case 1. So case 1 is when both the values are 0. So you can take x is equal to 1, y is equal to 1, right? So if x is equal to 1, y is equal to 1, what you get? Already what you have learned? A is equal to dx, b is equal to dy, which means what? A is equal to d, b is equal to d. So from this, what we can say? A is equal to b is equal to d, which means what? A, b are same. So same numbers you can take. So you can take what are the same numbers in the given question? A comma b should lie from where to where? 10 to 30. How many values you will get? Can we take 10 comma 10 one pair? 10 comma 11 comma 11 one pair, because a comma b should be same, and 12 comma 12 we should take until and up to 30 only. Why 30 only? Because in the given question a comma b should belong to 10 to 30 only. So now how many such pairs are there here? 21 pairs are there. 21 pairs are there. See, next one, next case 2. So when do we take case 2? So we have to take case 2. Case 2 is what? Take x is equal to 1 and y is not equal to 1. Then also product will be 0. X is 1, y is not equal to 1. So now x is equal to 1 means what? A is equal to dx, right? B is equal to dy. Now x is equal to 1 means what? A is equal to d. Now A is equal to d, you substitute here. What about here? B is equal to ay. So now B is a multiple of A. B is a multiple of A. Now what are the values you can take? See, if you take here A as 10, 10 into 1, 10 into 2, like that. So you take A is equal to 10. So 10 comma 10 already repeated. Y is not equal to 1, right? Y is not equal to 1. So what can you take here? Y can be 2, 3, 4, like that you can take any values. So Y you can take 2, 3, 4 and so on you can take. So A is equal to 10, D, right? First you take A is equal to 10. A is equal to 10 means what now from this equation, what is the B value? 10 10 value 3, 10 30 we will get, because up to 30 only, 10 comma 40 won't come. Next take A value 11. You can take A value 11, right? So if you take A 11, What about here B? 11 into 2, 11 comma 22. 11 comma 33 won't come, right? Then you can take 12, 12 comma 24. 12 into 3 won't come because that will exceed 30. Now 13 you take, 13, 13 into 2, 26. Then you can take 14, 14 and 20. Next you can take 15 and 30. So how many values we got here? So here 7 values we got. Still we are left with another case. So what is that? So x is not equal to 1 and y is equal to 1. So now let us take another one. So you can take here x is equal to, so case 3. Case 3 is nothing but x is not equal to 1 and y is equal to 1. See, you can take here x. See, now x is not equal to 1 means what will happen? See, a is equal to dx and b is equal to dy, right? Now y is 1, right? Now b is equal to d. So b is equal to d, you can substitute here. So what you can write here? A is equal to bx. So a is a multiple of b. A is a multiple of b. So now a is a multiple of b means we can here. So y is equal to 1 is constant and x values we can vary. Xy value we can comma 3 comma 4 and so on will be. So now y1, right? So y1 means what will happen? Now b is equal to d. Now can we take b value as 10? So already if b value 1 means x cannot 10 comma 10 already came. So we can take 20 comma 10, right? And then we can take here 11 comma 22. So 30 comma this value won't come. So next what do you get here? 33 won't come. So then we'll go for so 10 comma 20 comma 10. So 30 comma 10. Then when you take a as then take b as 11. So what you will get? 11 comma 22 comma 11 and here 33 won't come. Remaining will get like this. Next you can take b is equal to 12. So same as like this only, reverse space will get same as like this. See here 10 comma 20 comma 10 comma 11 20. So here 24 comma 26 comma 13 same way only. So here also will get how many pairs? 7 pairs will get. So how many total values? See, total values are 21 in the first, 7 in the second, and again so how many values we got? So 35 values we got. Okay, so hope it is clear. Another Ioqm question. So 2 questions they asked recently. Very important concept for this one, LCM and HCF, because based on this we can get a minimum 8 marks. So possibility is there. So now look at here. So this is the question they gave. M, N are natural numbers such that M and N are natural numbers such that M plus 3N minus 5 is equal to 2 times of LCM of M comma N minus 11 times of GCD of this. So how to solve this problem? So we have already learned, right? So you consider M and N are numbers, right? Take M is equal to dx, M N dy. Take M is equal to dx, N is equal to dy. Okay. Now substitute here in this one. We know that LCM we should take dxy and GCD we should take as d. Now substitute these values here. So how can we substitute here? When you replace M, see the given question is M plus 3N minus 5 is equal to 2 times LCM of M comma N minus 11 times GCD of M comma N. Now replace M value here. What is M value? Dx. plus n value dy, 3 into dy minus 5 is equal to 2 into LCM is what? dxy, 2 dxy minus 11 into GCD of this one is 11d. So now let us simplify this. See, we can take d common. So let us bring all the things to one side. What will happen? Dx plus 3 dy minus 5 minus 2 dxy plus 11d plus 11d. So is equal to 0. So because all the terms are multiples of d, d here, d here, d here, only 5 is left out. Let us send 5 to right hand side. What will happen? Dx plus 3 dy minus 2 dxy plus 11d is equal to 5. Now right hand side, you let us take common d value. So if you take d common, what do you get here? X plus 3y minus 2xy plus 11 is equal to 5. Now here we need to understand 5 is a prime number. Only what are the factors? 1 and itself, right? 5 into 1. In the question, if you observe, they are asking maximum value of m plus n. Maximum value of m plus n. So m plus n is nothing but what? M plus n is nothing but dx plus dy. When you take d common, we are going to get d times of x plus. We want to get maximum value of d. So here we will not take d is equal to 1. We don't take d is equal to 1. We are not going to take. Why? Because to get maximum value, right? So we need maximum value of m plus n. D into x plus y. These are all positive integers only. So to get maximum value, of m plus n, we take. So what value we will take? We will take d is equal to 5. So we take d is equal to 5. Hope it is clear for everyone. Now see, look at here. Now d is equal to 5. When you take d is equal to 5, this will get cancelled, right? So what I can write now? X plus 3y minus 2xy plus 11 is equal to 1. So this is the value we are going to get. Now when you simplify this, what you will get? X plus 3y minus 2xy plus 10 is equal to 0. Now we have to factorize this. So how to factorize? If you observe clearly, these two terms we can take x common. So let us take x common. What if you take x common? X into 1 minus 2y. Now plus, here we have 3y plus 10 is equal to 0. See, when you are factorizing, here x into 1 minus 2y. So 1 minus 2y we have. So let us consider 2y minus 1. So it will be easy for us to solve the problem, because 1 minus 2y we may get little problem. So let us convert. So multiply with x. Now let us simplify. Multiply with the minus. What will happen? 2xy minus x minus 3y minus 10 is equal to 0. So this makes our problem easier. So what we do here, now you take x common here. If you take x common, what will happen? 2y minus 1. See, while factorizing, we should observe that again same term should come. Here also 2y minus 1 should come. Like that we have to factorize. In order to get 2y minus 1 term, what we should take common? Minus 3 by 2 we should take common. Look at here, minus 3 by 2 into 2y. So minus 3y will come, minus into minus, plus 3 by 2 is additionally we are getting. So let us subtract that minus 3 by 2 here. So hope it is clear for everyone. See, what I have done is, here we have taken x common. We got the term 2y minus 1. If we want to write it as a factor, so definitely here also 2y minus 1 factor should come. That is the reason what I have done is, first I have written 2y minus 1. So here I wrote 2y minus 1. So like that we will simplify terms. In order to make this 2y minus 1, minus 3y should come. So here I can write minus 3 by 2. Minus 3 by 2 into 2y minus 3y, minus into minus plus plus 3 by 2. So that 3 by 2 I should eliminate, minus 3 by 2, and minus 10 as it is I will write. Even if you multiply and simplify, it won't change. Now look at here. Now can we take 2y minus 1 common in this, right? 2y minus 1 if you take common, this is x minus 3 by 2. Now minus 3 by 2 and 10, send it that side. 3 by 2 plus 10. This is nothing but what? 23 by 2. So hope it is clear for everyone. So now you need to simplify this. Now you need to simplify this. So how I'm going to take here 2y minus 1 into x minus 3 by 2 is equal to 23 by 2. Okay. So now let us simplify this. What is the LCM on right hand side? Okay. So this is 2y minus 1. 2y minus 1. Here LCM is 2. This is 2x negative 3 is equal to what will come here? 23 by 2. See, we can cancel these two. Now you are going to get 2y minus 1 into 2x minus 3. 2y minus 1 into 2x minus 3 is equal to what? 23 you will get. Now here 23 is a prime number. So what are the factors possible? Only two factors, right? 23 into 1 or 1 into 23. So hope it is clear for everyone. Now here two cases will come. What is case 1? Case 1, you take 2x minus 3. 2x minus 3 is equal to 1 and 2y minus 1 is equal to 23. 23. What is 2x value? 2x is equal to 4, right? And what about x value? X is equal to 4 by 2. 2. Now 2y minus 1 is equal to 23. 2y is equal to 24. What about y? Y is equal to 12. And the most important point we have learned. So what is that? That is x and y are co-primes. X and y are co-primes. But here x and y are not co-primes. Why we should not consider this as a case? Because we have taken m is equal to dx and n is equal to dy. If you take x is equal to 2, if you take x is equal to 2, y is equal to 12, what will happen? M is equal to t. D we have taken 5. 5 into 2 and n is equal to what? 5 into 12. This is 10. And what about this? This is 60. See, clearly this HCF is not 5, right? So here GCD is not 5 here. GCD is not 5 here. So this case we should not consider. Hope it is clear. So this case is failed. Now what value we should take now? We need to take another case. What is that case? Case 2 we have to consider. What is that case 2? So 2x minus 3 is equal to 23. Now 2y minus 1 is equal to 1. 2y minus 1 is equal to 1. Now what is the value here? 2x is equal to 2y minus 1 is equal to 1. Now what is 2x is equal to 24? Sorry, 26. Now what about here? X is equal to 30. 2y minus 1 is equal to 1. 2y is equal to 2. Now what about y? Y is equal to 1. See, now we got the values right. See, now x is equal to 13 and y is equal to 1. They are co-primes. They are co-primes. So now we can take. So m is equal to dx, n is equal to dy. We already know that d value is 5. So this is 5 into 13. M value. This is 65. N is here 5 into 1. So n is equal to 5. Now m plus n value they are asking, right? So m plus n is equal to 65 plus 5. What is this value? This value you will get as 70. Maximum value of m plus n is 70. So this is the previous recent Ioqm question. So answer for this question is what? 70. So this is the very important. This is how the questions will be asked in Ioqm. So see the simple logic we have seen. See, now just we see what we have learned in this class. This is the most important. Let's consider a and b are two numbers. Okay, you have to consider a is equal to dx and b is equal to dy. The most important point is x and y are co-primes, and LCM is dxy and HCF is d. Okay, now here we have taken one example, LCM of 52. Take dxy and d, and we already know that xy and x plus y, if xy and x plus y are co-primes, their HCF, here you will get 4. Now here 7 and 6 are co-primes, right? 24, 28. So one pair is possible. Now we have seen the second HCF value. Here we got 3 pairs are possible here. Okay, see next one, we have seen the previous Ioqm question 2022. So here we have seen, so how many values of ordered pairs of a comma b are possible? So here 35 values possible. Okay, and this is the 5 marks question in Ioqm 2022. So to get maximum value of m plus n, so we have to factorize. See, once you simplify these values, we should factorize to get maximum value. D possibilities we have to 1 and 5. To get maximum value, we should take 5. And here you will get 2 cases. You will get, in one case we get x and y are not co-primes, 2 and 12. So we are not supposed to consider this one. We should not consider d value 70 you will get. So this is how the problems will be asked. So this is generally so these problems are different from what we ask in the regular school curriculums. So we need to practice this kind of problems. When you solve more problems, we'll get more ideas, so that we can solve the problem. Because regularly how we solve the problems, it is completely different from Olympiad problems. So in this way, we need to practice and we have to think differently. So then we can do well. Okay. Okay. Thank you all for joining this session. Okay. Okay, sir. I'm going to wind up the session. So it is already 9 o'clock. We'll continue tomorrow.
Okay, sir. Thank you.
Thank you, sir. Thank you,
sir. Doubts any man 2 days
yes, sir. 2 days tarvata.
Okay, sir.
Separate ga.
Okay, okay. Thank you.
Thank you.
Recording stopped.